Hi, and welcome to the section on orchestration in the Lernard.com Jenkins chapter. In the last section, we installed and configured a Jenkins server. We've got it talking to Git and cloning repos for us automatically, and then performing a series of build steps on them as defined in our Jenkins file, and eventually deploying them to our AWS web server. This diagram shows the rough structure of the pipeline we've made so far, with our trigger and variables defined first, then a pipeline containing a stages block, and each stage containing steps. Finally, we have any post steps that are required, such as email or status messaging outside of the pipeline at the end. Hopefully this adds a bit of clarity to the work we've done so far, but I also made it to illustrate something new. If we switch the steps and stages here to our specific case, you can see that at the moment we're doing build and deploy related things with them, which isn't really a surprise, as we initially said that Jenkins would be used to automate our build and deploy layer in the DevOps stack. But in fact, as some of you may have already noticed, all we're really doing is using it to run shell commands. It would be true to say we didn't have to do this with shell commands, and we could have gone and found plugins that would have handled certain things without them. But really, we could quite easily have just written a few lines in a bash script to do what we're doing here, one containing npm install, build, and the SCP deployment, and it would do exactly the same job without all the faff of running a Jenkins server. Not only that, but those of you who sat through the previous chapters on Ansible can probably also see that Ansible allows us to do all of the things that Jenkins does pretty easily, at least in terms of running these npm commands and the SCP. So I think it's really worth us asking the question at this point, what is Jenkins really doing for us? Why would we use it rather than say Bash or Ansible? Firstly, Jenkins is custom designed to integrate with source control and check for changes using automated triggers. It would be easy to run bash commands in a file or from Ansible, but significantly less easy to have it constantly checking Git for changes, which is a key part of the full automation story we're trying to achieve. Also, neither Bash nor Ansible run as a service by default, and though it would be totally possible to do this, Jenkins does it out of the box in moments, including the authentication required. Secondly, Jenkins provides a simple visual aid for us to see the status of our pipeline. Ansible does have some visual aids available, especially if you're willing to pay money, but Jenkins has been designed to be immediately easy to see which pipelines are running, where they are in that pipeline, and what their status is. Jenkins also provides a clear historical record of the previous jobs that have run and what their status were. Thirdly, Jenkins makes build status and logs easily available, and if desired, they can be forwarded to an email box or messaging system with very little effort. These three things combine to make Jenkins far superior to something like Bash or Ansible for building and deploying code. The ease of use and the feature set is just that much more specifically geared to the task. But the point I'd like to make really is that it doesn't mean that these are the only things that Jenkins can do. In fact, it's an excellent tool for automation in general. As we've discussed, here we have a tool that will essentially do anything you can achieve from a command line on any remote computer and keep an attractive visual record of what has been done and whether it was successful. If we take a look at what we're so far achieving with Jenkins here, we can expand this model out now to include the other layers of the stack by adding provisioning and automation into Jenkins itself. This doesn't mean we aren't going to use Terraform and Ansible, of course. Terraform's cloud integration would take years to replicate in Jenkins using Bash, as would Ansible's awesome galaxy of idempotent modules. But as both Ansible and Terraform are themselves command-line based tools, we can simply call these from Jenkins, thereby wrapping each of them with the benefits of Jenkins' incredible dashboarding and historical record-keeping abilities. So now, as shown in this diagram, when Jenkins detects a change to the code for our web application, it will automatically deploy a server using Terraform, configure it with Ansible, then build and deploy seamlessly to that newly created server ready for testing. In essence, we go from nothing but stored code in Git to a fully configured stack in minutes without having to perform any manual work at all. There are many forms that this kind of orchestration can take as you alter the various tools involved, but once you've seen Jenkins handling all the stack levels of a deployment, the understanding of that concept can be applied to any other type of automation. A fully automated, version-controlled and idempotent pipeline that delivers code to a finished product. I'm not going to lie to you here that this chapter is a little longer and significantly more complex than some of the other ones, but once you understand and are able to replicate without help everything it contains, you can confidently call yourself a DevOps engineer and let no one say otherwise. So, now you're hopefully fired up with enthusiasm, let's run screaming to our Ubuntu VirtualBox VM and get started. First, as usual, we're going to open up Visual Studio Code. And now, as before, I'm going to make a backup of the Jenkins file in this section, so there's a record of what went on here for any pilgrims to later walk this path. But please feel free not to bother doing this bit yourself unless you particularly want to. Now that's out of the way, before we start creating any code, there's a small amount of preparation we need to do in the terminal. In this section, we're going to be using Jenkins to run Terraform and to run Ansible. As some of you will remember, for our Terraform to work, we need our .aws folder to exist in the home directory of the user that's calling it, populated with valid credentials. And for Ansible to work, we need SSH keys that can be used to connect into the servers that Terraform has created. Jenkins considers its own home directory to be /var/lib/Jenkins, the same path we've been looking at the workspace in, and the one you'll most commonly use on a day-to-day basis. Unfortunately, those of you that haven't done the previous Terraform and Ansible chapters will struggle to follow along with this directly, as because this section combines all 3 chapters, you're going to be missing certain settings that we cover in those chapters. Your 2 options are either 1. Go back and have a look at the install section of each chapter, as those will be enough to allow you to continue here, or 2. Feel free to just watch along with this section anyway, but not actually duplicate the code. It will all still make sense, and you can get the gist without doing it, though it's never quite as good in my opinion. So, that being said, for the rest of us, let's simply copy our .ssh and .aws settings into the /var/lib/Jenkins folder. So, cp-r/home/lernard.aws to /var/lib/Jenkins. And then I'll do the same for .ssh here. Now that's done, because the Jenkins user will be the one that needs to access these, we need to make that user the owner. So let's first chown -r Jenkins:/Jenkins /var/lib/Jenkins.aws. And then, after that, the same for .ssh. Great! So now Jenkins is ready for our Terraform and Ansible sections. I should say though that this isn't the only means to give Jenkins these AWS and SSH configurations. We could also do this with private credentials that are used as environment variables, and I think there's also more than one plugin that will handle the AWS credentials securely. But we're just going to use the easiest and quickest to understand way right now, as the fine details of security will vary from workplace to workplace in any case. Let's go back into VS Code here, and firstly I'm going to delete all these stages we have at the moment. In your case, you might want to save these somewhere convenient, though you'll be able to get them from the Lernard GitHub repo later if all else fails. Let's also delete the post section here too. I'm getting rid of these so we've got a nice blank canvas to create our code on, so it's clear what we're up to. But later on, we are going to put all of these stages back. First then, let's create a new stage, open some normal brackets and call it provision-terraform, followed by some curly brackets. Inside these, we'll open up a steps block here by writing steps and some more curly brackets. And now I'd like to introduce a new and super useful feature, the directory block. The directory block, written dir, indicates what the current working path should be within the workspace. So here, if I open a pair of brackets and write Ansible in quotes inside it, then Jenkins will now use the Ansible directory as its current working directory. If the Ansible directory doesn't exist, it will automatically create a directory with that name in the workspace. Inside this dir block, I'm going to cut and paste 3 lines of code that I nicked straight from Google, which you can either steal from here or you can Google it yourself by writing Jenkins Git plugin if you'd like to read the full article on how it works. The lines are used for cloning a Git project other than the one we're currently working in. So in this case, we want to clone our Ansible repository down into our workspace. If you're wondering why the Ansible repo when we're on the Terraform stage, it's because I'm planning to use the Terraform that we created in the Ansible repo, because it's nice and tidy and won't spin up too much extra cruft that we don't need. The first line here states git branch, followed by the branch of the repository we want to clone. The second line states which credentials we should be using for this, and the third line specifies the URL of the Ansible repository from GitHub that we're going to clone. To find your own particular credential ID, let's quickly hop over to Firefox and browse to our Jenkins server. Click Credentials here in the main dashboard, and under the Jenkins store you can see here this lengthy ID that I've highlighted, and that's the one you want to copy and paste. If you created your credentials slightly differently in any way, Just take the ID here of whatever you've got. Right, let's jump back into Visual Studio Code. So far, we've got a stage that creates an Ansible directory, switches to it, then clones the Ansible repository into it. Now we're going to write sh for shell executable, but instead of writing a pair of quotes like we normally have been doing, I'm going to write 3 quotes all together in a line. This opens up a shell block, just like 2 curly brackets opens up a block. But between 3 quotes like this, we can write a whole load of bash commands, just as if we were writing a script, without having to write sh on every single line. Because we've cloned the Ansible repo down into this folder, hopefully there should now be a terraform_web_server directory that we can browse to. So our first command, I'm going to write cd terraform_web_server. As we did in the previous chapters, we initialize this with terraform init. And now on a new line, we're going to immediately run it with terraform apply. For this example, there's no point writing terraform plan, as because it's going to be fully automated, there's no one around to see if the plan is sensible or works in any case. I'm also going to write -auto-approve after this apply statement, so that Terraform won't even wait for a user to confirm whether or not it's sane, it will just apply the Terraform straight up, whatever the case. This does mean we want to be pretty careful with what's actually in Terraform when we're using this method. But we're not looking to make alterations to our entire estate here, we're just spinning up one web server. In an industry, we'd be able to use multiple test environments to make sure all was well before going to production with it. Okay, that's looking good for our Terraform code, so let's close off the shell executable block with another 3 quotes. Already, this chapter is a bit more complex than some of the previous sections, but rest assured that what we're doing now is, aside from a few missing nods in the direction of security, the equal of most things you're going to come across in the enterprise. Enterprise deployments might be a lot larger, but we're introducing a lot of complexity here in a small space, and if you can get comfortable with this, you won't meet anything to faze you in interviews or jobs. That being said, I want to introduce the concept of a script block. Do you remember much earlier at the start of this chapter, we covered the difference between declarative and scripted Jenkins, and that we would always be using declarative. Well, there are 1 or 2 times in declarative that a piece of functionality would be easier to achieve if we were using scripted Jenkins. And if we ever want to access those features, all we have to do is write the word script like this and open up a pair of curly brackets, and then we can use scripted Jenkins while inside this block. I didn't want to overcomplicate things too much at the beginning, but this is another feature in the cap of declarative in my opinion, because accessing the power of scripted is there easily anyway if we need it. In this case, my reason for doing this is that I want to assign the IP address of the Terraform instance we create to a global variable. If you look at the very top of our Jenkins file, you'll see the variable we defined in an earlier section, server IP. Now we're spinning up our server dynamically, we don't know what that's going to be, so we can't just write it out like we have done before. That 3.84.143.200 isn't going to be correct. To calculate what the IP should be, I'm going to use the AWS command and request the IP from the newly created server, then assign that value to the global variable server IP. Let's have an in-depth look here at the command I'm going to use to do that. Initially then, the basic command is AWS, then EC2, which is where the instances of servers live, then the subcommand describe-instances to get details about the servers that currently exist. That alone would give me a huge list of details about size, memory, name, IP, disk and all that for every server running, but I specifically only want the public IP address of our web server and nothing else. Next then, I'm going to filter that list with the --filter option, followed by specifying that I want the name tag to be Lernard_webserver, although of course in your case change this to whatever you choose to call your server. I'm then going to use this query option to give me only the instance public IP address, and then finally I'm going to choose text as the output format. Don't worry about remembering all this, I got this from Google and it took me a couple of goes to get it correct in any case. The AWS command is amazing for doing this kind of thing, but it's by no means the only way we could have done it. We also could have made Terraform output those exact details and then filtered the output. Working out stuff like this is always something you'll do by trial and error, and a whole lot of search engineering. We'll be running this command from our provisioning step, so the other thing I need to do is pass it back into the global variable defined at the head of this pipeline, so I can then use it in other stages such as configure and deploy. Okay then, so I'm going to cut and paste that in now. Here then you can see server IP, then equals, then I'm opening up a shell and following it with normal brackets for the options. As you can see, scripted is different from declarative. I'm going to specify script, and then our command in quotes, then return stdout equals true, so the result is populated into the variable, and then finally I'm going to write trim here at the end to remove the new line that it's going to have on it. This is not a piece of code that's easy on the eye, and I'm certainly not suggesting you remember this. This section is very much about the concept of orchestration, and to see it properly requires a bit of gnarly one-off code. But don't really worry about replicating the specifics of this until you need it in anger. Feel free to just copy it. I have been saying this a fair bit, but the internet really is your friend when it comes to tricky bits of code. Stealing from someone else's GitHub and then working out what it's done and understanding it is a surefire way to increase your skill. Once we've assigned the variable server IP with the value of the public IP address, let's echo out the result here so that it appears in the logs and it will be easy to see whether we've got it right or not. And finally, we need to remove this hard-coded value here as we're not going to be using it anymore. There's a lot going on in this stage. Downloading the Ansible repo, running Terraform, getting the IP, and then assigning it to server IP. But that's it. Now if we push all this great code back to GitHub, we should hopefully see Jenkins spins us up a beautiful web server. So, jump back into the terminal here, cd into the Jenkins repo, and then as always, git status, git add-a, git commit and our commit message, and then git push origin master. Now that's done, we're ready to kick off the build in Firefox on the Jenkins server. As before, I'm going to make a new build job for this, but it's going to be identical to the previous couple of build jobs, looking at exactly the same repo. I'm only doing it to keep things tidy, and to give us a clean history and a clear view of where we are, so feel free to just keep using your same build project if you want to. So, I'll just click New Item here, give it the name Section 6, choose Multi-Branch Pipeline as always, and now once more I'm going to add our Jenkins repo as the source here. Credentials as usual, and then save. We can see it looking for a Jenkins file again here, and now it's found it, it's kicked off our build of master. Great! We can see it's picked up the new code and it claims to be doing some Terraform. If I click on the stage here, we can drill into the logs and get a better idea for what it's actually doing. That's looking good. We can see there that it's downloading the Terraform plugins, so at the moment we know it must be midway through the Terraform init part. Actually, it would be pretty cool to see our Terraform instances apply while we were watching the pipeline. So let's open up a new tab here and browse to the AWS console. Into EC2 here, and then back to running instances. And at the moment it's blank, so Terraform must still be mid-creation. Let's go back to our pipeline so we can see the progress and know when to look back in AWS. Okay, there now, it's finished. So now, if we hop back into the console tab and refresh the instance list, perfect! Jenkins has used Terraform to spin us up a couple of instances. Of course, we don't really need this database instance, it's just there as an artifact of our Ansible section. But that's okay, as these servers are really cheap, so we can just ignore it for now rather than spending the time making new custom Terraform. However, if you want to make something more bespoke for this practice though, it would be an excellent use of your time, so do feel free to pause and have a go if you fancy it. We can see the public IP address on the right here is 35.168.22.121. So let's check it out in Jenkins on that address to see if it matches what it's populated into the server IP variable. And yes, we can see here that the echo statement is declaring our server IP variable to match, so it's all working nicely. Cards on the table here, I should say that as this is a video, if anything ever goes wrong when I'm writing my code, I just edit it out to make myself look like a legend. But at this difficulty level, you should expect to get multiple failures before you get something right. I mess up all the time in work at the development phase, as do all of my colleagues. It's an expected part of creating code like this, and I wanted to be honest about that so you don't feel bad if you have to do 10 or even 20 iterations before all of your stuff starts to work. Our Jenkins phase is looking pretty good now, So let's head back to VS Code to create the Ansible one. As before, we start with a stage, open a pair of normal brackets, and then quotes for the name. Let's give it the name configure-ansible, followed by opening a pair of curly brackets. We'll start with a steps block, and once more we're going to use the new dir block to specify that we'll be working in the Ansible directory again. Just like before, we'll open up a shell executable block now with triple quotes, and in fact I'll make the closed triple quotes here too, so we can just stick some code in the middle. Right, this time we're going to cd into the section 6 folder, which remember is in our Ansible repo which we've cloned into the workspace we're in now. I'm choosing the section 6 folder just because the Ansible playbook and roles that are in that one are the most advanced because we did it at the end, so we'll get our fully working Apache web server if we run that one. Now we're going to use rm-f to delete the Ansible hosts file that's in here, as that has hard-coded values in from the last chapter that might mess with our deployment. In its place, we need to make our own hosts file using our newly created server IP address that we've got in the server IP variable. Let's quickly go and have a look at that format so we know what we're trying to create. I've got the Ansible repo cloned here already, so I can just cd into it like so. And we want the section 6 folder, and then vim hosts. So here we can see the format we're going for. In this case, we're only going to be creating the web section here, so that should be pretty straightforward to do with an echo command. I'll just switch back to Jenkins here for later. And now back into VS Code. For anyone who doesn't know, echo can be used to populate files as we're going to use it here. It's pretty standard bash and ultra useful for exactly this kind of thing. So, echo, and then the file began open square bracket, web, close square bracket, then we want a new line character, then web1 space ansible underscore host equals, and then our server IP variable. Then to output that to a hosts file, we do angle bracket right, then hosts. If you're not familiar with this trick, have a play around with it on the command line. Unlike some of the other stuff we've used in Bash today, this is well worth remembering. It's a great general purpose tool for outputting small files, and you'll probably use it again over the course of your career. Next, we want to make sure that this stage doesn't try and apply any Ansible until the server is actually up and available. As a Terraform spin-up isn't instant, we know, it takes a bit of time. To do this, we're going to create some bash that checks to see if port 22 is available, and only stops checking once it has successfully found that the server is up. We're going to use a while loop, which will do exactly that. Keep repeating something while a condition is true or false, depending on what we specify. So, we write while, then an exclamation mark, which means we want to keep this repeating only while the next statement is failing, and to stop when it succeeds, followed by NC, which is short for netcat, a classic Linux connection tool, then -Z, which means check the port is listening only, then -W5 for a 5-second timeout, then the server IP so it checks our server, and finally the port, which is 22. Now we write a semicolon, which is a command separator, similar to pressing enter on the keyboard. Then do space echo, open quotes, waiting for server as our message for the logs. Then another semicolon, sleep space 5 to create a 5-second wait. Then a final semicolon, then done. I do apologise for how bash heavy this section is, but as DevOps is a bash heavy job, it's probably worth getting used to it if you're not already. Bash isn't always elegant, but like kicking a television, it's quick and it gets the job done. If you aren't familiar with while loops though, don't worry about it for now, just copy the code straight from Lernard for this section and it's all good. Now we've done that slightly tricky preparation, we're ready for our Ansible command. If you sat through the Ansible chapter, can you remember it off by heart? Ansible-playbook-i hosts, then the name of the playbook, so in our case, playbook_web.yml. And that's it for the Ansible stage, it's good to go. We need to push this code to master, so I'll blast a quick fast-forwarded git status, add, commit and push here. There we go. And now let's jump back to our Jenkins console and check this out. Rather than waiting for the 15-minute auto trigger, I'll just kick off a manual build here. We can see we're building the right thing because the commit message confirms it. So let's hop in and take a look at the logs to see the progress of applying our Ansible configuration. And here we go, it's running the playbook here. So in the logs beneath this, we can see it going through each one of the Ansible tasks in turn, installing and configuring Apache, plus a load of other stuff we put in the Ansible chapter for practice that we don't really need here. But don't worry, as it's not going to harm anything. Great, success! Now it's done with that, we should be able to browse to the web server and see the placeholder website that Ansible put there. Let's copy and paste the IP address from AWS, and then stick it in a new tab to browse to it. And there we go, our placeholder is serving correctly, which means the firewall is correct, the server exists, and Apache is configured properly. If we look back in the Jenkins Section 6 project here, we can see that part of the process took 1 minute and 53 seconds. The Terraform only took 18 seconds this time as the server already existed, but previously it took about a minute, so we can go from absolutely nothing but code to a fully configured and built web server in about 2 minutes, which is definitely acceptably quick to have as part of a build process. Whenever I'm automating things in industry, checking the times like this is something I do, as developers won't be very happy if you accidentally double the length of their build. They're going to be waiting on the results of build jobs quite a lot, and there's no way to say how long is too long for a particular build. It just depends on what you're trying to achieve. But I do find that anything under 5 minutes never seems to annoy anyone, and anything over 10 minutes starts generating tickets and queries entitled, "How can we improve the build process?" Perhaps it's related to the amount of time it takes the average person to go to the toilet or make a cup of tea. But in any case, even though this is a reasonable length of time to be doing a build, it's conceivable that developers might not want to re-provision every time. As you can see in the second run, Terraform didn't really do anything in that run because the server already existed. Just as an exercise then, let's go and add a quick feature to allow us to make both these stages optional. So, back in Visual Studio Code, we're going to copy this parameter here and make another identical one underneath. We're going to use one of these for the provisioning step and one of these for the configuration step as switches to turn the features on and off. So first I'll change this here to say provision, then the same again for configure, and once more the description. Now, at the top of the provisioning stage here, we can use when, just as we did for the deploy branch to make it only apply on master runs. But this time, inside the brackets, we're going to write expression, then another pair of curly brackets, then inside here, we write params.provision equals yes in quotes. So it's only going to run this stage now if the provision parameter exactly equals yes. Let's copy this whole line here and paste it to the top of the configure stage. And of course, change the param to configure. Okay, that should be all we need to do to make these changes optional. As always, a quick fast-forwarded git add, commit and push to master. And perfect, now we can switch back to Jenkins and run our build again. On the first run here, it will just use the default settings rather than asking me, which you may remember are the first options in each case. So in our case, that would be no. So we're expecting this to run a build that basically does nothing. And there you can see it's just got 2 blank squares for provision and configure. So now let's run that build again. And here now it's scanned the new settings, we're getting the options to choose if we want these things to occur or not. So now I'm going to choose yes in each case, so we can see this run through fully this time. And there we go, so our stage toggles are working there. If we'd rather have used checkboxes instead of drop-downs, we could have achieved that with Boolean parameters for this. Both are pretty easy to implement, so it's totally up to you which you prefer. Finally, in this section then, now we've got our provision and configure stages done, let's add back in our build and deploy stages so we can see the whole stack run through from start to finished product. So back in VS Code, I'm just going to copy all the stages from the install dependencies to deploy. If you haven't got these anymore, feel free to just nick them from the code at Lernard GitHub, as they will be identical for my project as for yours. There's no project-specific values in this part. Back in Jenkins file, let's paste these directly under the configure stage. And also, as we're not using a parameter for strict host checking anymore, let's change this back to a hard-coded no. And that's it. We're only a git push away from DevOps perfection here, so I'll run a quick fast-forwarded one of those one more time. Okay, so here we go. This is an emotional moment, as it's something of a finale. For any of you who've gone all the way from the basics chapter to this, if you get a green build eventually, please do email me and tell me about it. There's going to be plenty more great DevOps after this in later chapters, but this is the first moment we're running the complete picture. This is our victory lap. So let's choose yes to both of these, as we want the whole 9 yards here. And in fact, let's make this as impressive as it can possibly be here by quickly jumping back to AWS and terminating our servers. So we really are starting with a blank canvas. There we go. I'll just quickly wait for these to fully shut down. Right, go. So, it's downloaded our code from GitHub. It's provisioning servers in AWS from that code. Now it's using Ansible to configure the server with Apache. Now it's installing dependencies needed for the React project to work. Okay, dependencies are done, and now it's simultaneously building and testing the code. And now finally, it's deploying our built web app to the fully configured server. Success! If we refresh our AWS console here, you can see that it's recreated our 2 servers, so I'm going to need the new IP address. And now, the final proof of the pudding. Our compiled, minified React website exists on our perfectly configured server. There we go then, the whole DevOps stack delivered from code to web app, with all server provisioning and configuration along the way. We've delivered on what we said we would from the very first introduction of this chapter, but so far we've just got Jenkins installed centrally on our laptop, which is not very scalable, especially in industry where there might be hundreds or even thousands of builds going off. With that in mind, we're going to take a look at build agents in the next section. So, hopefully see you there.